Good morning. Today we're going to take a look at review of independent and dependent probabilities, mixing them up. One of the things I want you to be aware of is when you guys are doing the steps for the work, take some time to write down what does each event look like, so that when you refer back to the questions in terms of writing down each probability, it'll make it more clear to you when you are solving your answer. So focus on writing down your work in words first, and then the math will follow. So keep that in mind as you're working through it, and keep asking questions as we go forward. So as I said, we're going to mix up some independent dependent events. So one of the things we're going to focus on is, can we determine if the events are independent and dependent from the words? So when we are reading it, the words are going to tell us it's going to be independent or dependent. Can I clearly identify the individual events? Make it visible, okay, as you're going through. So that's going to be one of the things that we're going to try to work through this. So how do we determine whether if the pair events are independent or dependent? Well, in dependent, you're looking for the words given. Okay, so in the statement of the words given, that's going to clearly say that B given A is important. All right. And if it's independent, okay, there's not going to be any use of the word given. So when you're looking at it, given is not going to be used at all. For independent, we can use those things. All right. So use the probability formulas that we have given you, pardon the pun, moving forward. Okay. So let's look at some of these formulas and or questions, and hopefully this will build some bridges moving forward. The probability of a warm day on the weekend was 68%. The probability of someone getting a sunburn given that it's a warm day is 95%. Keyword given. The probability of a sunburn given that it's not warm is 18%. Yes, it is possible. It was not warm this weekend, and I did get sunburn, so that is possible, but very unlikely. So this is dependent. Okay, because the word given is used. So keep that in mind as you move forward. So after we've done that, we have to figure out what are the two events that I'm looking at. And we can look at that based on the words in the question. Sunburn has to be give B because it's has to be dependent given that it's a warm day. Okay, so sunburn is my B, and warm day is A. All right, so that's the next step you want to look at. Now define your probabilities. All right, so this is where I look at my question and find all these out. So I have a probability of A. I have the probability of A prime. I have the probability of B given A, because it says that in the question. And the probability of that one, B given A prime, B prime A prime, and B prime A. So we should be able to define these from up there. All right, so I'm going to push pause and I'm going to write them down and I'll tell you how I got them. All right, so to find my answers for PA and PA prime is from the question. Probability of A is 68%. There it is. Now I can find the complement. Okay, that's how I got the 32%. All right, I'm going to push pause again, and I'll tell you what the given probabilities are in a second. All right, so how I got the 95% for B given A, it says it right in the question. B given A is 95%. I want to make it green. All right, from here, the 18%, it says getting a sunburn, B given A prime. That's where I got that from. All right, and then you want to find the complements of each of these. So the complement of that one is that one. All right, and the complement of that, all right, is that. So all this work helps us to build up those connections to define these. Okay, so we haven't answered the problem. This is all this work right here is all the startup stuff that we've done. Now, sunburn. All right. So that's going to be, we want to find this. Okay. The question is how? Well, we don't know. It depends, right? It depends on if it's a warm or not warm day. Okay, so what we might have to do is split these up into two separate scenarios. All right, so I can have a warm day and sunburn. Or not warm day and sunburn. All right. So what we're actually going to do, and I'm going to type this out by hand here. I want to find the probability of A and B. And then I'm going to add the probability of A prime and B. All right. And if I went back to my original formula, that formula for dependent probability times probability of A plus probability of B given A prime times probability of A prime. All right, so those are the formulas that we've given you at the beginning. Okay, so looking over to your left part of your screen, we have all four of these scenarios figured out over here. We don't have to look back up here to figure that out. That's why this is important. You've taken the words and make it in notation, so it makes the substitution easier. Okay, so now I can simply just do B given A, which is 0.95 times 0.68 and then I can do A prime, so that's 0.18 times A prime, which is 0.32. So I can find that information pretty easy. All right, so now I can go 0.95 times 0.68, 646. And then I can do 0.18 times 0.32, 0.0576. And then I can just add those together. So I can take 646 plus the 0.0576, 7036, and then I got my answer. All right. Therefore, the probability of getting a sunburn this weekend is 0.7036, or about 70%, because it's going to be warm this weekend. 68% chance of being warm, 32% being cool. So that depends. So it's heavily weighted that direction. All right. So we could figure out that information separately, and we can add those together. All right. Or you could work backwards to say the probability of not getting a sunburn this weekend is about 30%. So, all right. Probability of rain this weekend is 64%, and the probability of Mr. Brizzy raking the leaves this weekend is 76%. So that's what it is. My wife has told me to do it, therefore I must do it. Okay. So in this question here, this is independent probability. All right. So no given in question or answer. Okay. So what's the probability of Mr. Brizzy doing the raking and it rains? Nope. No given in there. Okay, what's the probability of Mr. Brizzy not doing the raking and it doesn't rain this weekend? That's there too. Okay. So the second thing is the same thing, is define your variables. So take the time to define your variables. All right. So A is rain. A prime is no rain. B is raking. B prime is no raking. So take the time to do the work. All right. Define the probabilities. Okay. So if I look up here, probability of rain is 64%. So therefore, probability of A is 0.64. Probability of raking is 76. Well, that's B. All right, and make sure you find your complements as well. All right, so A prime is 36 and B prime is 24. Okay, so now we can answer our questions. All right, what's the probability of doing the raking? So actually that is B. And it rains. So when you write this out for A, you can keep it as probability of A and B. Okay, you can do that. So that's the probability of A times the probability of B. Okay. All right. And part B, I can look at it and say, doesn't do the raking, so that's B prime, and it doesn't rain, that is A prime. All right, so I can go back, and for part B, I can say the probability of A prime and B prime. All right, so each of the letters are going to be prime because in the original sentence, they're primed as well. All right, so take a couple of minutes using the probabilities that you found. All right, answer the questions, and then I'll be back. All right, so I've got my answers here. I've got 48% that if it rain, I do the raking and it rains. All right, and I've got 8.64% if I don't do the raking and it doesn't rain. All right, so I can write some therefore sentences for that too. All right. So hopefully you got, the purpose of this lesson is to figure out if it's independent or dependent. Once I find that, then I can define my variables to find the probabilities, answer my question. All right, so it's all about the defining part. All right, a local survey was conducted to see where graduating students will do, or where they go, or what will they do for next year. The results are below in the chart. What's the probability of choosing a student going to university given that they're female? Ding, 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 ding. These are dependent probabilities. Okay, so soon as I saw the word given, soon as I heard that word given, the bells are going off. Okay, what's the probability of choosing a male given that they're going to college? Okay, so there we go. So we have to define our variables. So we're going to look at part A. We're going to let, the question now is, what has to be my independent or dependent variable? Well, sometimes it's written in the question. Probability of student going to university, there's my B, is university. Because B has to come first with the given that they're female. Okay. All right, so we're going to find that. So we're actually finding, I'm going to scroll down a little bit more. I have to find probability of B given A. All right, and in my formula, so that I will give you guys, and I think it's on the next page. All right, we're asked to find that. So I have to look up now to figure out what do we know from that. Okay, so the probability of university and male, or university and female, right there. Okay, so we know that there's 35 females that are going off to university, but we don't know the total. So we gotta maybe add up some of these columns going across. So we've got 25 plus 65 plus 10. Oh, that's a nice number, 100. And then we got 35 plus 50 plus 5. We've got 90 females, so this is out of 190. So let's work down. 25 plus 35 is 60. 65 plus 50 is 115. And we've got 15, and that adds up to 190. So if we're looking at this, we know that there's a total of 190 females and are going to university. Divided by the total females. Well, I know that there's 90 total females. Okay, so looking at that, now I can just solve this. So this is 35 over 90. All right, and we all know try to reduce our fractions. All right, so 35 over 90. If I divide the top and bottom by 5, so I got 7 out of 18. Okay. So there's my first question. Done. The next question is, I have to go back and define my letters again, because these are dependent probabilities change a little bit when it says problem. Choosing a male, there's my B, so B is male. Given going to college, there's my A. All right, so if I write down my formula again, so B given A, so that's the probability of A and B over the probability of A. That does not change. Okay, the numbers we put in there. So how many males go to college? 65 males go to college. Okay, how many total go to college? 115 are going to college. Okay, so now I can do 65 over 115. Okay, I can reduce my fraction this way. And I think if we divide by 5 again, this becomes 13 over 23. If I divide the top and bottom by 5. Okay, so those are the basic steps that I'm looking for. All right, so if we're looking at define the variable, figure out what each letter represents, figure out the probabilities from each part, sub it in. That doesn't change. Okay, it doesn't change from what we did up here. All right, we define our variables, define the probabilities, use our plug it in. Okay, so when you're practicing some of these events, okay, use these. Okay, so I've got this formula, I've got this formula, and I've got this formula. So those formulas didn't change, but the numbers that we put in were. All right, give that a try and let me know how it goes.